Welcome everybody. Go ahead and get started. My name is GS Kalsa. I'm a technical marketing manager here at VMware, and I'm here today with my associate, Manoj Krishnan. He's one of the engineers for HA, and together we're going to be telling you a little bit about some best practices for HA, and we'll give you some tech previews for both FT as well as a couple of new other things related to HA that we're working on. So, how many people were at the general session this morning? Just about everybody? Anybody surprised about the announcement about FT there? Nobody? I was. I didn't know they were going to do that. So, basic disclaimer, you've seen this before, same thing at the general session. We're not technically promising anything, no dates, no specifics, no features, things like that. So just high-level overview before we start drilling down. When you think about availability, you really break it down into three different categories. So you've got high availability or local availability, disaster recovery, and data protection. And all three of those are what give you your business continuity picture. Today, we're going to be talking about HA and FT, which both fit into that local availability category. A little bit about our agenda. I've already kind of gone over this. So just quick recap, what was new in 5.5? So in 5.5, probably the biggest thing that we did from an engineering standpoint was the integration with vSAN. vSAN obviously was new in 5.5, but there was a lot that went into making that work. And Manoj is going to get into a lot more of the details and the best practices around that, but just from a what's new standpoint, that was the big differentiator. One thing that I just want to, I would imagine, well, let me just check. How many people here have been to VMworld before? So how many people are new to VMworld? Better question. Okay, so just so you know, in case anybody hasn't told you before, all these slides are going to be available to you around maybe a week to a couple days after this. So you're welcome to take pictures of slides, you're welcome to do anything that you want in that regard, but you'll get PDFs of all of them afterwards, as well as you'll have access to recordings of all the sessions, the demos, everything. So just so you know that. So a little bit of a recap on HA, just to kind of level set everybody before Manoj dives into the best practices. So HA is going to minimize your downtime, and it's going to automatically recover your VMs if you lose a host. It also will recover your VMs if the VM crashes for some reason, and if you turn on VM monitoring, it's going to recover the VM if your OS crashes. So it provides a couple of different levels of protection. One of the big things to keep in mind with HA is it's, as everybody probably knows, it's really easy to set up and configure. There's not a whole lot to it. You can dive into a lot more of the details, and that's where some of that complexity gets into it, and Manoj will drill into that, but initial setup configuration, really easy to do. And the other big thing is that it's completely OS and application independent. Doesn't matter, as long as the OS is supported by vSphere, and almost all of them are, and whatever application are running on that VM, your VM is supported, protected by HA. So what does an HA cluster look like? So you've got one or more hosts. Well, you have to have more than one host, I should say. You're going to have one host that's elected as the master, and then the rest of them are slaves. You've got two methods of heartbeating that go on for that communication between the master and the slaves. So you've got network heartbeating and storage heartbeating. And again, Manoj is going to drill into a lot more detail about best practices for all this stuff. The big thing to keep in mind from a network standpoint is just one differentiator is when you use vSAN, you're not going to be using the management network for that communication anymore. You'll be using the vSAN network. And with that, I'll hand it off to Manoj, and he's going to talk about failure events to begin with.
Thank you, GS. Hey, my name is Manoj Krishnan. I'm one of the engineers in the availability organization, and I'm also the tech lead for HA. So before going into the best practices, I would like to give a quick recap on some of the failure events and how HA handles that. So here is an example of cluster of 6 hosts. When HA is turned on for the first time, what happens is VC pushes and installs the HA agents on these hosts. And we have something like a master-slave model. Once the agents are up and running, they go into an election mode, and one of the agents will become master, and the rest of the agents, they become slaves. Now, what the master is responsible for is it monitors the host, it monitors the VMs, it reads the protection list, and it knows what are the VMs that needs to be protected, and continuously monitors them. So there are 2 channels that the master communicates with the slave. One is the network, which is the primary one. As a backup, we have the storage communication. So let's say in case of a slave host failure, master notices no communication in the network and the storage, and marks the host as dead, identifies what are the affected VMs, restarts them on healthier hosts. Now, if a master host is dead, all the agents on the healthy host, they go into election mode again, elects a new master, and the master will read the protection list, identifies what are the VMs that needs to be protected, and restarts the VMs that was originally failed on the master. So in case of, say, a switch failure or a link failure resulting in a network partition scenario, you could have more than one partition. In this case, each partition will have a master. So a couple of things I want to mention. One is, which VC is going to talk to only one master. So it depends upon which master VC is talking to, it will have the perspective of that master. Say, for example, if VC is connected to a master on partition A, it will mark those hosts as master and slave, and the hosts on the other partitions as network partition. And the other thing I want to mention is, let's say you have a network partition scenario and one of the hosts fails. It is not guaranteed, or not necessarily the VMs will be restarted on the same partition. It depends upon which master owns the VM, which master owns the protection list that has those affected VMs. So based on that, the VMs will be started on the respective partitions. So in a worst case scenario, there could be a case where a host on partition B fails and all the VMs are starting on partition A. So next failure event is a host isolation event. The HA agent will declare a host isolated if it is disconnected from the master, it does not see any election traffic or the agent traffic, and it cannot ping the isolation address. In that case, it will declare itself as isolated, and if you have heartbeat data store, it will communicate to the master and let the master know that I'm isolated, and master will take actions. So that I'll go into more detail when I talk about the best practices section related to host isolation. So the first topic I want to talk about is networking and storage. The networking and storage best practices we have covered extensively in the previous VMworld. So I would encourage you to look at those videos because it covers a lot of scenarios. But I'll cover some of in this case, I'll give you some highlights and cover some key points. So the first one is the networking recommendation. I'll just talk about the top 3 bullets. So the first one is the redundant HA network. So recall that the HA agents, their primary mode of communication is through the network. So it will be great if there are more than one network for the agents to communicate. In a typical scenario, HA uses the management network. So if there is a redundant management network, it's good. Or in case of a VSAN setup, it uses the VSAN network. So if you have a redundant management network, that will be also good. And the other one is have fewest hops possible. This is nothing specific to HA, but in general, fewer number of hops, fewer number of components, so less chance for network failures. The third one is consistent port groups. So if you have, let's say, VM network, if you have consistent port groups on the host, then the compatibility for the VM can run. You have more hosts that the VM is compatible with. So in this case, if there is a failure, there's a good chance that your VM will be restarted elsewhere. So, and let's say if you're doing some network maintenance and you don't want HA to restart the VMs, then disable host monitoring, and HA makes sure the VMs will not be restarted in case of network maintenance. And this is not just for, the second point is about having separate subnets. If you have redundant HA network, have them on separate subnet. I mean, this is not specific for HA, but a general VMware recommendation to keep them on different subnets. It's because if they are on the same subnet, then there's a good chance if one NIC fails, then basically you lose the redundancy because traffics are mostly routed through one of the VMK NICs. So you would lose the redundancy. So it's good if they're on the different subnet. And if they're on the different subnet, by default, HA picks up only one isolation address, which is the default gateway, management gateway's address. So if you have multiple subnets, you could use the HA advanced options to provide more isolation address. Bottom line is just keep things simple because you can predict the failure scenario. It's easy to manage. Next one is the storage. So recall that network is the primary mode of communication between the agents, and if there is a network partition or isolation scenario, the agents communicate using this storage. So we use something called heartbeat data stores for that communication. By default, when HA is enabled, it will pick 2 default data stores for heartbeating. Most of the cases, you don't have to override them, but let's say it picks up a data store that you think it's not resilient enough. There might be another data store that you might have, which has more than one HBAs, or it's better fault isolated from the network. So in that case, go ahead and override the default heartbeat data stores. The next topic is about HA vSAN integration. As GS mentioned, in 5.5, we had a significant investment went through to fully support vSAN VMs. But I'll just highlight some of the differences. This table highlights some 3 key differences. This was mentioned earlier. So on a vSAN-enabled clusters, HA uses the vSAN network just because so that both HA and vSAN have a holistic approach of, whether it is a network partition or isolation, they see the failures the same way. Other one is the heartbeat data stores. Heartbeat data store is primarily when you don't have network. So we don't use vSAN data stores for heartbeating because whenever there's a network failure, there's a good chance that the data store is also gone. So we only use the traditional data stores for heartbeating. The last one is host isolation. So in case of a vSAN cluster setup, use the gateway address of the vSAN's network rather than the management network. So though heartbeat data store not required in a vSAN setup, it's useful in some scenarios. So what happens is, in case of a host isolation, the HA master will restart the VM on another healthy host. Now you have 2 powered on VMs on the cluster. The problem is, the vSAN network is down. That's why there is a host isolation. And because you don't have any data stores, the master is going to restart the VM. But the VM network could be up. Now 2 powered on VMs, and you have MAC address collision on the VM network, which you clearly want to avoid. So it's better if you have, it's not required, but if it is not too much of a big deal, then it's recommended to provide a heartbeat data stores. And the next topic is with respect to isolation address. I just want to see how many of you normally override the default isolation address in a HA cluster. Okay.
Nobody?
Good.
Really?
Okay, it's good that I have this slide. So in case of a vSAN cluster setup, it is strongly encouraged to override the isolation address. So these are the advanced options. Set the use default isolation address to false and provide the vSAN network's gateway as the isolation address. And if generally isolations or partitions are possible, ensure one set of isolation addresses is available. And this is especially important if the vSAN network is non-routable. So you have to provide an isolation address from that subnet that's not affected by the in this case. Or the other option is HA gives you a way to provide up to 10 isolation addresses. So you can just randomly pick other hosts' IP addresses and provide them as default isolation address. Only if the HA agent cannot ping any of these isolation addresses, it will declare it as isolated address. As long as it can ping one of these address, it won't declare that host as isolated. So that's another option. And this is the same comment applies for VSAN. If you have a redundant VSAN network, make sure they are on unique subnets. There are a lot more details and more explanation, nice pictures on the blog here, so I would encourage you to read that blog as well.
Just a quick question. How many people are using or planning to use vSAN? Anybody? Okay. Cool.
So this topic is host isolation responses. So how does HA determine a host is isolated? If everything is good, the host is like connected slave, which is connected to a master. Once it loses connection to the master, it goes into an election mode. If it does not see any election traffic or no other messages from other agents, and if it cannot ping the isolation at any of the all the isolation addresses, then it will declare itself as isolated. Once it declares itself as isolated, if you have specified isolation policy for the VMs, which I'll be talking about in the other slide, and it will apply the isolation policies to those VMs, and it will also notifies the master via data store heartbeat that I'm isolated. Otherwise, the master will consider that host as dead. So in 5.1, we added an advanced option to delay the isolation response. Thanks to your feedback, what happened was in some scenarios there was some network glitches or some intermittent network failures, which was expected. In that case, some of you had said that we don't want HA to be aggressive and apply the isolation response immediately, an option to delay this isolation response. So from 5.1 onwards, this is there. So based on your environment, if you know what the timeout is, you can use this option to specify the timeout. The default isolation responses leave powered on, don't do anything. So there are shut down and power off for the other two options. So which one should you choose? Well, it depends. Yeah, yes.
Is the default delay 0?
The question was, is the default delay 0?
The default delay is, I believe, it's 60 seconds, but it's configurable. So which one should you choose? Whether you should leave powered on or shut down or power off? Well, it depends. It depends upon what is a common isolation scenario in your environment and what is the type of VMs you are using and what is the state of the setup in case of isolation. So I'll go over into some of these cases detail. So what are these things? Whether what type of VMs you have, and during isolation, are your VMs going to retain access to the storage? The other question is, will they likely retain access to the VM network? So based on these questions, there are various scenarios, and these various scenarios have various recommendations. So I'll cover them in detail. So for the first case is actually very straightforward, very simple. It's a it's a traditional VM, and in case of a network isolation, the VM is going to retain access to the storage, and the VMs have access to the network. So which means VMs are running fine. So why power it off? Just leave powered. So the recommendation is select the leave powered on, which is the default option. So next one is the VMs have access to the storage, but it lost access to the network. Now, if the VM's network access is important, which is typically most of the cases, then you can do a shutdown of the orderly shutdown of the VM. And once you shut down the VM, the master will be able to restart the VM. As long as the VMs are powered on, the master will not be able to restart the VMs.
So just a quick thing to throw in there. Some of the times when I've been sitting where you are and gone through this slide, I had the question of how would you tell you're in one of those scenarios? And so just like for this scenario, a quick example would be if you had fiber channel storage and a regular network. So in this example, your host is going to, let's say your network goes down, so your host is going to retain access to storage, but it's not going to retain access to the VM network. And then an example of the other way where you're going to lose access to storage and retain access to network could be either a converged network situation where you lost just a particular VLAN, or if you had separate networks for your storage and your networking and you lost just your storage network. So hopefully that helps just a little bit with clarity on that.
Okay, thank you, GS, for the clarification. So that's the second case. So now, the bottom two rows, it slightly depends upon whether Normally in an isolation, in your setup, if an isolation affects only one or a subset of hosts, or it's a total cluster isolation. So based on that, you might have to have the setting. So let's assume in a typical scenario in your setup, isolation means it's a total cluster isolation, which means all the hosts are isolated. So in that case, you don't want to apply the isolation policies to shut down or power off the VMs, because in case of a total isolation scenario, there is no master available to restart the VMs. So all the VMs will be shut down, which you don't want that to happen. So in that case, leave the VMs powered on. But if it is only a subset of hosts that will have that are affected by host isolation and does not have, and the VM also loses access to storage, then there are other factors that you must consider, which I'll probably go into the detailed C file. I'll do my best to explain this. Okay, so let's say in case of a network isolation scenario, right, and the VMs have no storage, if there are is heartbeat data source available and are they accessible? Well, if the answer is yes, then the master will know that, okay, the VMs are powered on elsewhere, so it's not going to pronounce that host as dead, and it's not going to restart the VMs. So in this scenario, host isolation, VMs lost access to the storage, and heartbeat data stores are available, then what you should consider is the memory state important? Well, if your memory state is important, then you should leave them powered on. If it is no, then you could either power it off or leave powered on, based on what you want HA to do. Now, let's say there are no heartbeat data stores available, but if there are no heartbeat data stores, recall that the master will consider that host as dead, and it will be able to, it will restart the VMs on other hosts. Now, in that situation, if your VM network is still up and running, then what happens is you might be in a situation where you have two powered on VMs, and there's a collision in the VM network, the MAC address collision in the VM network. So if that's a scenario, then power off the VMs. Otherwise, check if your memory state is still important. If it is important, set the policy based on that. The next topic is admission control. So I just want to see, how many of you think admission control functionality is fairly limited? Okay.
Nobody thinks it's at all limited?
Okay, but yeah, that's good. But we have quite a number of feedback from you that there is some limitations in the functionality, which I'll go over it. So what is admission control as of today, and what it is not? So admission control is used to reserve some resources, and in case of failures, the VMs, there is enough capacity available to fail over or to restart the VMs. Though you have enough capacity to restart the VMs, it is not always guaranteed that they'll be performing at optimal level, right? Well, that's clearly a gap, right? Because you don't want only the VMs to be restarted, up and running, but they should have the right amount of resources so they can perform optimally. So we are working on a Flink solution to close this gap, and in one of the tech previews, we will demonstrate how to answer that question. And we also have a group discussion on Thursday that we will be discussing about this detail, and we would like to hear your feedback during that time as well. So how to do admission control? So based on your scenario, there are various admission control policies available. Pick up the default, pick up one of the policies that's right for you, and ensure DRS is enabled, so that what DRS does is it nicely balances and makes sure the VMs have enough resources if they are fragmented or not available. So once you have selected, you want to ensure whether in case of a failure, will my VMs will they be able to restart and they'll be performing well. One way that you can do right now is you can put the host into maintenance mode and check if the VMs are all migrating and all are they not able to migrate. If they migrated, are they happy? Well, that's kind of disruptive because you don't want to do that in a production environment. So that's why we have a Fling solution. We are proposing a Fling solution which is completely, which is slightly different, and it's less, and it's practically not disruptive to your environment. So now based on your simulation, based on your results, now you know, okay, this is the failure simulation that I have the results for. Now you can make some adjustments to make sure to handle those failure scenarios. What could you do? One is you can maximize the utility of remaining healthy hosts. If you enable DRS in automatic mode, what happens is DRS will always make sure if some of the, during a failure, if some of the VMs cannot be restarted, it will try to move around the VMs and make space available for you. Also, increase the compatibilities of hosts that the VM can run. So, which means there's a likely chance that in case of failure, the VMs will have, there will be more number of hosts the VM can fail over. Also, ensure there is sufficient capacity in the cluster. And if you cannot ensure sufficient capacity in the cluster, one way to ensure, at least for the critical VMs, you can increase their restart priority. Now, the restart priority is what it does is it ensures the higher priority VMs will get the resources first. It's not that they will be powered on first or they'll be restarted in that order. Well, we are working on a solution to address that problem. We have heard a lot of feedback that the VMs have been restarted in a particular order. So we are calling that as a restart ordering, and we are going to discuss this in the group discussion as well on Thursday. So we'd like to hear your feedback on that one as well. So now, recall I said there are multiple admission control policies. As of today, we have 3 admission control policies: percentage-based, number of hosts, which is also known as a slot-based algorithm, and dedicated failover hosts. A lot of details are available in the clustering deep dive book by Duncan and Frank, and also on the blogs. So I would encourage you to read that if you have not already done that. But I'll give a high-level overview and some recommendations.
Just one quick question. How many people have admission control enabled in their clusters?
Okay. Yeah.
Okay. And how many people, if you have admission control enabled, how many people are using slot-based? Host failures cluster will tolerate. Just a couple. Percentage-based? Okay, most everybody else. And then dedicated failover host? Just a couple. Okay.
Okay.
Thanks.
So the percentage-based policy is very straightforward. So it takes, you take the total capacity of the cluster for the VMs. The capacity is based on CPU and memory. And if it's 100%, you can allocate a certain percentage to use during failure. So in this example, we have 25% of CPU and 25% of memory reserved, and that will be only used during failure scenarios. Percentage-based scenario, it's often the best choice. It's because if you have an environment where the standard deviations of your VM capacity sizes are really high, right, then percentage-based policy will ensure that it's going to maximize the use of these resources. And only one problem with this policy is, say you're reserving a policy. In this example, you have a cluster of 6 hosts. You're simulating a single host failure scenario, and based on that, you are reserving a percentage of 16%. Now, we are adding or removing hosts. This is going to stay constant. So the only thing is, if you're adding or removing hosts, you have to adjust the percentage based on your failures or your worst case scenarios that you want. The next policy is the number of hosts policy. It's also called as the slot-based policy. So what is a slot size? Slot size is basically a logical entity that can fit any powered-on VMs in the cluster, which means it will have the CPU size and memory size to accommodate any powered-on VMs that is already in the cluster. So in this example, you have 4 hosts. You have a 4-host cluster, and you have 12 slots. So if you have selected a single host failure scenario, three slots will be dedicated for failover slots, and which means you have only 9 slots available to power on VMs. If you're trying to power on more than 9 VMs, then the admission control will not let you. This policy, it ensures there are resources available during failures because it's based on slots. However, one of the disadvantages, it's a most conservative policies, right? If you have one large size VM, then that is going to be the slot size, and all the smaller VMs will be using those huge slot size, resulting in waste of resources. So in that scenario, the recommended option is you can always go with the percentage-based policy, or if you have only a very few really large VMs, you should use the dedicated failover host. That's another option which I'll be talking about. So this is a dedicated failover host, and in this case of cluster of 6 hosts, you can dedicate one or more hosts as failover hosts, and in that case, if you can select a failover host such that it has largest capacity to accommodate the VMs during failures, then the biggest disadvantage is it will reduce the impact of VMs that are running on other hosts. So during a failure scenario, most of the VMs will be failover to this dedicated failover host. But there's a disadvantage in that also, because since all the VMs are restarting on the same host, the restart time could be. And another disadvantage of this policy is, there are no failure scenarios that host is sitting there idle. So. Now we'll go to the tech previews. We have 3 tech previews. I'll hand over to GS.
So while I pull this up, well, let's see. First, I guess we'll just talk about these first, and I'll ask questions as we go. So everybody heard, how many people, I asked this before the session started, but how many people were in the general session today? It was just about everybody there. So anybody excited about the FT announcement? Yeah? Cool. Okay. Hopefully that's at least part of why you're here. Oh, okay. Yeah, and I will. So during the general session, they announced that in the vSphere beta, the vSphere 6 beta that's going on right now, that FT is one of the features that's featured in that beta. So if you want to get your hands on using FT, that's available right now through the beta program. And that beta is an open beta, so you don't need an invitation. Just go in, sign up for it, download the bits, and start playing with it. And in the announcement, the way that the beta is working right now, it supports up to 4 vCPUs. So just taking a quick step back, FT is the next step up from HA in terms of availability. So when the time that it takes for HA to detect that a host has failed or a VM has failed, and the time that it takes for that VM to restart, if that's too much time for you, if you need a higher level of availability where you need like 0 data loss, 0 downtime, then FT is that solution. And up until now, the problem has been that we've only supported it with 1 vCPU, which severely restricts the number of workloads that you can protect with that. So in the beta, we're now supporting up to 4. Just out of curiosity, how many people have workloads that you'd want to protect with FT that would fit into that restriction? Okay, cool. So just a real quick, I already talked a little bit about the way about what FT is. A quick recap on what it does. You're basically taking changes that occur on one VM, sending them across on an FT logging network, and implementing those changes on the other one. Now, the original version of FT was using what was called lockstep. So it was doing everything exactly at the same time. This version is slightly less granular, but we're talking extremely small amount of time, slightly less granular doing that. So I will walk you through. We've got one live demo that we're gonna do, but we have the other ones are recorded just to make sure that we didn't run into issues with the demo gods. So, and this is one of the examples that we've heard a lot of people that are kind of excited about FT. This is one of a really nice use case for that, or a potentially nice use case, and that's protecting vCenter. So let's just kick this off. So in this case, you see that we've got a vCenter VM. It's got 4 vCPUs. It's got 8 gigs of memory. It's got a bunch of hard disks. And you can see that it's running on the FT086 VM. And we'll scroll down here in just a second and take a look at what the secondary VM, which is number 83. So we've got an FT-protected vCenter. Now we're going to take a look at what the IP address is of that, and then we'll go over to a tab that's us connected to that vCenter. So just to verify that it is an actual vCenter, that it's functional, that it can do things, navigate to a VM, look around at a little bit at configuration. And in just a second, you can see it's that VM, the memory and everything matches. And now we're going to pull up a PuTTY session, connect right into that VM, or that host. We'll get logged in. And you can see the name of that host matches what we're looking at. And let's take a look and see that we are running that VM on this host. Pull up ESX top, you can see it again. And now we'll just reboot the host. So normally, if the host that your vCenter is running on gets rebooted, you're going to lose all your connectivity to vCenter. Obviously, we lost access to the PuTTY session because that host went down. But you can see that vCenter's chugging right along, doing exactly what it was doing before, still functional. Everything still works the way that it was. So that's what FT gives you. One of the key things to keep in mind, in this case, we're protecting a vCenter server appliance. If you're protecting vCenter, in the case of the vCenter server appliance, more than likely you've got the embedded database. But if you're going to protect something with FT, obviously, and it relies on something else, make sure you're protecting both components of that, unless you've got some other level of redundancy built into it. So the next one that we're going to talk about is VM component protection. So in 5.1, we introduced some capability of protecting your VMs from a PDL situation. And it's an advanced setting, and it's a little bit involved to configure, and it doesn't work quite as well as we'd like. It's not as fast as we'd like. And we've had a lot of feedback that APD and PDL situations aren't currently handled well. So what this will do is, this is your host detecting that you have either an APD or a PDL situation. And this is strictly with your storage, obviously, because we're talking APD, PDL. It's strictly going to look at the access to your data stores. And if it detects one of these situations, it's going to kill the VM rather than waiting for it to die on its own, because once the VM storage is gone, the VM's not going to be able to recover. And then it's going to restart that VM on another host. So you could end up in a situation where you've got both, say, Fibre Channel or iSCSI and NFS, and you lose just one of them. So let's just say you lost your NFS storage. So in this case, the VMs that are running on the NFS storage are blue. The ones that are running on the Fibre Channel storage are gold. So you lose that NFS, you lose your connection to your NFS server, lose that storage, and it's not really a migration. You're talking about actually killing those VMs and restarting them on the other host. But up till now, in an APD situation, if this happened, those VMs are still just going to sit there. So what we're going to demonstrate is showing you what it looks like, what this solution could look like, and how that's going to work. So just pull this up. So right now, here you're taking a look at the configuration screen. So you get an idea of what some of the options are that you're going to have available. Again, these are not saying that this is the way that the product's going to end up. This is just an idea, and we'd love to hear your feedback about that. So you'll have, in this case, you got separate options for how you want to deal with APD and PDL. You can have it just send an alert or actually fail over the VM. Give a delay if you want it to wait a certain amount of time if you're in an APD situation, and then what exactly you want it to do. So what we'll do is we'll take a look at one of these hosts, and we'll look at one of the VMs that's running on it. I'll first take a look at the storage. So got a couple of different data stores. Some of those are fiber channel. The first two that we're looking at were fiber channel, and this is the VM that we're going to test with. So we logged into that VM, looking at iometer. You've got stuff running. It's generating IOs, generating a workload. And now we're going to pull up our fiber channel switch configuration and just disable the ports that are going to that host. So you can see your IOs drop to 0. At this point, the VM is still alive, but it's not really able to do anything. Take a look in the events. Oh, we'll take a look first in our data stores. You're going to see that our data stores are now inaccessible. Now we'll take a look at the VM and look at the events for that. And we can see that we terminated the VM, and then in just a second we'll be able to see where we restarted it. So the VM was powered off. Now we'll refresh that and see that that VM was powered on, and it was powered on the other host that still has access to that storage. So that is VMCP. The last thing that we're going to look at is what Manoj was talking about earlier, which is a fling that will just allow you to simulate failures in your HA environment, give you an idea of what those failures are going to impact and what it'll look like without you having to put your host into maintenance mode. So I'll walk through this here in just a second. This one actually, we're going to try this live because it's a lot simpler. But basically the gist of it is you're just going to upload your file. It's going to give you a screen that's going to show you the estimated performance impact. Well, you're going to select what kind of a scenario you want to walk it through, and then it's going to show you that performance impact, and it'll give you a whole lot of detail about each one of those groups that are impacted by performance in different ways, the detail of that. So let me switch over. So this is what it's going to look like. We're just going to take our DRS dump file, drag it there. So we see that we've got 8 hosts and 60 VMs in this environment. We've got a couple of different choices. We can do a worst case single host failure. So this would be the largest host in your environment. You can simulate what it looks like to lose that. Or you can get into specific host failures. So in this case, we're going to say, what does it look like if we lose 3 hosts? So it's going to show you a little bit of detail about your environment, cluster overview. So in this case, we're going to have 3 VMs that aren't going to start at all. And one thing Manoj mentioned, I want to mention it again, is key thing to keep in mind with HA is HA and admission control is just going to make sure that your VMs can restart. It does nothing to guarantee, in its current iteration, it does nothing to guarantee performance. So it's just going to make sure that your VMs can restart. So what this is going to tell you is how your VMs are going to be impacted, if they're even, in some cases, if they're going to be able to restart, and if their performance is going to be impacted. So we can also look and see we've got a whole bunch of VMs that are just going to have be impacted by resource constraints. So they're only getting about, in this case, all of them or most of them are only getting 38% of the resources that they were getting before. And then in the last case, we've got 37 VMs that are unimpacted. And once we release this, we'll allow you to decide how those categories work, what you consider minimally impacted and what you consider a serious reduction. But the way that it is right now is this. And more than likely, we'll have this released in a couple of months. Just show of hands, how many people think that something like this would be useful? Awesome. Okay. Well, very cool. We'll definitely make sure we get the information out about it when it is available.
Just a couple of points. One is, this is not only for the next release or something, it will be available. This tool can be used for, from vSphere 5.0 onwards. The other key point I want to mention is, recall that it's going to solve two problems. One is the tool will show how many numbers of VMs are not restarted. So you can look at what are the VMs that are not restarted, so you can go and either increase the capacity or make some adjustments of those, make some preservation adjustments. And the second one is the VMs are restarted, but you can see how much of the performance is, what is the impact in performance, how much of CPU it's getting, how much of memory it's getting, and based on that, you can adjust your CPU and memory reservations. So, yeah.
So with that, these are a couple other things if you're looking for more information on HA and/or FT. Like Manoj mentioned, we have a group discussion on Thursday at noon. If you haven't been to a group discussion, I would highly, highly recommend going to one. It's one of the more unique features at VMworld. It's going to be in a small room. There's only about 50 people. You have a lot of chance to talk with whoever the expert is or the specialist is that's leading the session. It's interactive. They're going to really try and make it a group discussion as opposed to them just throwing PowerPoints at you. So I've looked around and there's tons of the group discussions, not just the ones that we're doing, but lots of group discussions that still have openings. So I would recommend that you fit those into your schedule, because keep in mind these sessions are all recorded. You can watch them after VMworld. The group discussions are not, so it's something that you can just do while you're here. There's also the Ask the Experts. If you're looking for just a little bit of one-on-one or as many as 4-on-1 time with an expert in different things, on the second floor of Moscone West, it's something you can't sign up through the schedule builder or anything like that, but you can just sign up in person there, and you can spend an hour talking to somebody like Manoj or one of the other, me or one of the other experts at VMware. And if this session just wasn't quite enough for you, we're also repeating it tomorrow. So I wanted to thank everybody. If you have questions, actually before I say that, make sure to fill out your survey. If you like the session, please fill out the survey. If you didn't like it, you don't need to fill out the survey. No. No,